Alright, so for number 3, create a function that matches the transformation. Remember that anything vertical is intuitive. When we write the function, it's going to look like what it does. So I'm just going to start by a generic f of x. And if I do a translation down, well, down you think negative, so just take a function minus 5. When I stretch by a factor of 2, it's just my function times 2. And the same thing, vertical compression would just be a third of my function. So now let's actually make a function instead of saying f of x. So I could just say f of x equals x squared minus 5. F of x is equal to 2 times x cubed. F of x equals 1/3 of x to the 4th. Now, anything that's horizontal is counterintuitive. So if I just start with f, remember, anything counterintuitive inside the parentheses. So left you think negative, but it's opposite of what you think. And so we actually write x plus 3. Now look, for vertical stretch was a factor of 2. We put a 2. Well, horizontal stretch, it's counterintuitive because it's inside the parentheses. So it's not by it's a factor of 8, but we write it as a fraction. And so now a stretch looks like this, a compression is going to look like this. And so now if we actually write functions, so let's say our function is going to be x plus 3 squared. Here f of x is going to equal 1/8 x to the 3rd, and f of x equals 3x, let's do to the 5th. Alright, and the last ones we're going to look at are the reflections. Okay, so when we go across the x-axis, it's just take the negative of the entire function. So if it's f of x equals negative x squared, and so reflection across the y is when the negative's on the inside, and so that would look like something like that. You might also want to go back and watch the videos on the Google Classroom about the transformations.